Hello, this video is going to be on rigid motion proofs. This is going to be our first video for our proof unit. And let's start off by defining what a rigid motion is. A rigid motion is when we move an object using transformations. And we've already talked all about transformations so far this year without altering its shape or size, which means we are preserving its congruency. We're going to move it, but we're not going to change anything about it except for its location. So let's review back on the transformations that we've already talked about and determine which one of those transformations are rigid motions and which ones are not. So again, rigid motion, the key about a rigid motion is that it doesn't change the shape or the size. If I translate, remember translations are just sliding of an object, which means yes, a translation is going to be a rigid motion. The reflection is the flipping of an object, which we discussed was preserving its congruency. A rotation is spinning an object, which is going to preserve its congruency. And then there's the dilation. The dilation, if you remember, is creating similar figures. It's the same shape, but we're changing the size. So a dilation does not preserve the congruency because it changes the size. So when we use rigid motions to create these proofs, we can use translations, we can use reflections, we can use rotations. We cannot use dilations because dilations do not preserve congruency. So what is a rigid motion proof? This may look familiar to you. We have done these kind of problems before. So the first part is going to be review. Explain the transformations needed to move triangle ABC to triangle DOG. So I want to get this triangle down here on the bottom left, and I want to use my transformations to map it or to match up my pieces to the triangle DOG. And then the last time we did this, we had A and A prime. So you knew exactly which ones had to be mapped to, so that's a little bit new. We have to think about how can I get them to match up, which pieces really correspond to each other. So if I kind of look, I have this right angle right here at B, and I have a right angle here at O. So I know that B and O are going to match up. And when I look at my statement, I'm going to have A matching up to D, B matching up to O, and C matching up to G. So if we use our translations, and if you remember back from the unit, there are many, many, many different ways in which you can map. I'm just going to give you one example. So if we start with our first one, I can translate up 1, 2, 3, 4, 5. So if I take this entire triangle and translate, slide every piece up 5, A is going to be here, so that's A prime. B is going to be here, giving us B prime. And C is up 1, 2, 3, 4, 5. Here is C prime. So I've translated my triangle, all pieces up 5. So translate triangle, tell me what you're moving and how you're moving it. So translate triangle ABC up 5 units. Once I get here, I need to map A prime onto D, B onto O, and C onto G. When I look at this, I see the y-axis, and I notice that A and D are equidistant from the y-axis, so I'm going to take A and I'm going to reflect it over the y-axis. So we are going to reflect triangle A prime, B prime, C prime over the y-axis. Now you could also say, instead of saying the y-axis, we know that this is a vertical line at 0. Either way, it doesn't matter, and that's how we're going to get our points to map up. So that's the old stuff. That's what we've done before. Nothing new there. But now, what makes them congruent? Why are these triangles congruent? This is the added new step. Triangle ABC is congruent to triangle DOG because, how do we know that's true? A series of rigid motions maps triangle ABC to triangle DOG, and we just talked about rigid motions preserve congruency. So if I can get one object to map on top of the other object using only rigid motions, which are the translations, reflections, rotations, then I know my two triangles or my two objects are congruent because rigid motions preserve congruency. This last statement, this is our proof statement. This is the new stuff. This is what we are adding to what we had already done in the transformations unit. And that is all for our video today.